All right, so in this video, we are doing a word problem on domain and range. We are basically given 800 meters of fencing, and we need to create a rectangular fence that's divided into 3 sections. Okay, and then we need to find the domain and range of the area function and then the dimensions that maximize the area. So in a question like this, the first thing you want to do is you want to draw a diagram of the situation. So we have a rectangular fence that's been split into 3 sections. I'll label the entire bottom here as my length, L. I'll label this height over here as my width of my fence. So if I look at this entire diagram, the area is just going to be length times width because that's the area of a rectangle. The perimeter of this fence is 2 times L because I have 2 of them here, plus 1, 2, 3, 4 W's. So plus 4W. And then I know that I have 800 meters of fencing, so I'm going to replace my perimeter with 800. Now I want to find the domain and range of the area function, but the problem is I have 2 variables here. I need to get rid of one of the variables, and that's what I'm going to use this equation for. I'm going to use substitution. Okay, now I usually isolate the easiest variable to isolate. In this case, it's L because the coefficient is smaller. I'm going to move 4W to the other side. And then I'm going to divide everything by 2. So this is going to isolate my L. Okay, just remember that the variable you are isolating in this formula is the variable you're going to get rid of in this question, because now we're going to replace the L with 400 minus 2W. So area equals to 400 minus 2W times W. So now this is my area equation over here, and it's a function of the width because I only have a width in this formula. If you wanted to get it as a function of the length, you could have isolated the width over here and substitute the width, and then you would have the formula in terms of the length. But in this case, we'll just work with the width. I need to find the domain and range of this function over here. So in order to do that, I'm going to first just solve it to find my x-intercepts. So 400 minus 2W equals to 0, or W equals to 0. I'll solve this one. 400 equals to 2W, divide by 2. So 200 equals to W. So if I think of this area function over here, let me do a quick sketch of it so that you can see the domain and range. This is a negative quadratic equation. The intercepts are 0 and 200. This is what the graph looks like. In order to find the range, I need this maximum height over here. So I know the x value over here is just the midpoint of these two. So that would just be 0 plus 200 divided by 2, which is a width of 100 meters. And this width of 100 meters will maximize my area because this is the maximum area up here. To find the maximum area, I just need to sub in 100 back into this equation. So I'll do that in my calculator. And I get 20,000 meters square, which is basically my y value at this point. So now I can finally do my domain and range. Since this is a real life situation, my domain is all real numbers such that x is between 0 and 200. And my range is all real numbers such that it's between 0 and 20,000. That's how you find domain and range. The B part says to find the dimensions that maximize area. So we already have the width over here that maximizes the area. The width is 100 meters. To find the length, I'm just going to sum in the width into this equation. So 400 minus 2 times 100 is my length. That's just 200 meters is the length. Basically, the length of this field is 200. The width is 100 of fence area, not field. And that will give us a maximum area of 20,000 meters square.